Hi physics students. In this video I'm going to show you a little bit about how to write equations from data graphs. So I've drawn three graphs here and I'll explain what I'm thinking of by labeling the axes on the first graph. So let's say this graph is a graph of horizontal position x in meters versus time t in seconds. And let's say the intercept is 2 meters and the slope is 1/2 a meter. I could write an equation for this that would be correct. That would be y equals mx plus b form, and that would be y equals 1/2 x plus 2. Nothing wrong with that, but it doesn't communicate anything specifically about what's actually graphed on these axes, horizontal position and time. In fact, it kind of confuses people because it's got x here with the horizontal variable when that's actually time. So if you know that x is the horizontal position, you might think that this equation is vertical position equals 1/2 times the horizontal position plus 2. So what we want to do is we want to communicate exactly what is graphed to people. So let's make this equation y equals mx plus b form, but with the specific variables that are graphed. So that's x in meters. That's what's on the vertical axis, so that goes where y is. And the slope is 1/2. And I know that that is in meters a second, so I'll go ahead and write meters a second, times the time in seconds, plus 2 meters. Okay, so now this equation communicates exactly what is graphed along with the units of what was measured. So now let's look at this equation. Again, we won't change it. We'll say, well, we could change it. Let's change it a little bit. Let's just say now this is y, vertical position in meters, and this is time in seconds. This graph goes right through 0, 0, and let's just say that this equation is a quadratic equation, and it's y equals 2x squared in math teacher form. So now, again, I want to write this in a way that communicates what the axes show. So I would linearize this graph, and I would do that by squaring t. And I'd say that y equals, y in meters, is graphed over time squared in seconds squared. So that this parent function is shown by the fact that we had to square the times to get a linear function. So now this goes with this graph because x squared is t squared, but I would prefer to write it in a form that has the specific variables on the axes and the units. So I'm going to do what I did before, and I'm going to translate this linear graph into that slope-intercept form. Y equals, y in meters equals, I know that would be 2 for the function I made up, 2 times t squared in seconds squared. And plus 0 would be the intercept because I tried to make it go through 0, 0, although you can see I missed a little bit. Now, what would be the units that go with the 2? Well, on the left I have meters, on the right I have seconds squared. So I must have some units that would cancel out seconds squared but leave meters. So that would be meters per second squared. If you're confused by that, you could say something like this. This is what how I usually think about it. If I have meters on the left and question mark is the 2 times seconds squared, well, question mark must equal meters divided by seconds squared. Aha, that's what I put there. So this is 2 examples of how to write specific equations using the variables on the axes and the units on the axes for linear graphs. I hope that this was helpful. Thanks for watching. Remember, what one fool can learn, another can.